This is my intermediate algebra course. Today we're going to learn the exponent rules. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. The exponent rules are a big part of the intermediate algebra curriculum, and it's extremely important that you learn fluency with those rules, because if you don't, you're going to have some big problems when you go into upper math courses. So let's do a little review. Here's an example, 3 to the 5th power. The green number is called the base and the blue number is called the exponent, but be aware that the word exponent and power can sometimes be used interchangeably. In fact, it's done all the time. You'll hear teachers say power instead of exponent. And technically, the overall expression circled in red here is called a power. You know, that's the technical word for the overall expression. Again, the blue is exponent, the green is base, and the overall expression is actually the power. So here's the power rules down here, or the exponent rules, whatever you want to call them. And so you can get a screenshot of those, and please take a screenshot, because you know, and really you should take a picture with your phones and have your phone in front of you so you can see these rules without having to go back, and you know, that way you'll just have it right in front of you. We're going to use these rules, and we're going to use these Roman numerals to the left. You see these Roman numerals here, so I've numbered each rule. That's going to help us identify what rule we're using for the rest of the class. So very important to take a screenshot of these rules. This color up here, that's rules that we learned in pre-algebra, and we're also going to learn 3 new rules that we haven't learned in my curriculum yet, and then we're going to learn 3, 4, 5 more rules that are what I would call strange exponent rules. They're going to be kind of strange. And so we're going to start with things, like I said, the first 2 rules that we learned in pre-algebra. It says here, simplify each expression below and write the Roman numeral of the exponent rule that you used in the margin. So we learned in my pre-algebra course that if you're multiplying powers, and the powers have the same base, then you just add the powers. So we have x to the 6 plus 4 power, which equals x to the 10th power, and you're done. That's it. And I'm going to write over here in the margin, the directions tell us to write the rule that we used, and that's rule number 1. And use a Roman numeral there. Now, even though we learned how to do this in pre-algebra, we didn't state the rule formally. And, you know, that's what this is here. It's stated formally. It tells us that if we're multiplying powers and you have the same base, then you just add the powers. Okay, I know this seems a little complicated, but that's all that's really saying. And, you know, I want you to understand that you don't have to use this intermediate step here. You can go right to the answer. I'm just using this so you can understand the formally stated rule. So let's try another one of these. 2 plus 3 is 5, and that's your answer. You're done. So these are pretty easy. Roman numeral 1 is the rule, so I'm putting that over here in the margin. And again, you don't have to write this intermediate step. So now add all those powers together. 4 plus 8 is 12. 12 plus 5 is 17. So we have x to the 17th power. Rectangle that, and that is Roman numeral 1. Now you might think this is kind of tedious having to write these numbers over and over again, but I want you to be absolutely sure where these, you know, which rule we're using. So even though that's kind of tedious to have to write that, I want you to do it anyway. Okay, so I want you to try number 4, and when you come back, we'll do it together. All right, we're back. So add those powers, and you get x to the 11th power, and that is Roman numeral 1. So if you got that answer, good job. Try number 5, and when you come back, we'll do it together. All right, we're back. So that's going to be x to the 13th power. I know this is kind of easy, but you know, again, we're just starting off small here. These are going to get a lot more complicated when we go into the next class. But also, there's going to be what you would call advanced concepts later on in this class. So again, if you got those answers right, good job. Try number 6, and when you come back, we'll do it together. All right, we're back. So 8 plus 7 is 15. 15 plus 4 is 19. So we have x to the 19th power, and we used rule number 1. Okay, so again, that was just all pre-algebra review. The only difference between what we learned today and what we learned in my pre-algebra course is, you know, we're stating the rule formally. So now we're dividing powers. We're taking this power here and we're dividing this power. And so in that case, we just subtract. We learned this in my pre-algebra course also. So that would just be x squared. And that is rule number 2. So again, you don't have to write this intermediate step. I'm just doing that so that you can recognize what's going on with rule number 2 here. If you have a power and you're dividing it by another power and the bases are the same, then you just write the base, and the resulting exponent is just the difference between the two exponents here. You just subtract. So again, we didn't state the rule formally in my pre-algebra course, but this is the formal statement of that. And you might wonder, well, what is this over here? Well, remember, when you have a fraction, you can't have 0 in the denominator. You know, that messes things up. So oftentimes you'll see this. That just means that you can't, x cannot be 0 in that particular scenario. So now over here, 7 minus 3 is 4. So we have x to the 4th power, and you're done. Easy. And so I want you to try number 9. Again, you're just subtracting the powers. And when you come back, we'll do it together. All right, we're back. 5 minus 2 is 3, so that would be x to the 3rd power. And that is rule number 2. So if you got that answer, good job. Try number 10, and when you come back, we'll do it together. All right, we're back. So 8 minus 6 is 2, so we have x to the 2nd power. And that's rule number 2. So if you got that answer, good job. Okay, so again, if you didn't get a screenshot of those exponent rules, please do that now. At this point, I'm just going to talk a little bit about why those rules work. So using this as an example, x to the 3rd power times x to the 4th power, you're just going to add the powers, right? Just like we did in the previous problems, and you're going to get x to the 7th, because 3 plus 4 is 7. So why does that work? Well, if you take x to the 3rd power and you expand it, remember, all that means is just x times x times x, all right? So we're changing x to the 3rd power to this expression here. Now, remember, x to the 4th, that just means x times x times x times x 4 times, okay? But now, if you get rid of those parentheses, you can see we're just multiplying these x's times these x's, so you get this expression here. You don't really need the parentheses. But now, why don't we just take all 7 of those x's and just change it to x to the 7th? So that explains a little bit about why that rule works. Now, if you didn't understand that, or you don't really care about that, that's okay. You don't have to know any of this. All you have to know is fluency when it comes to the exponent rules. Fluency means you know how to use them. So anyway, the conclusion there is rule number 1. If you multiply these, you just add the powers, add the exponents. Again, there I go, interchanging the word power and exponent. Again, that's typical. So now, if you take x to the 5th and you divide it by x to the 3rd, you just subtract the powers. But why? Well, x to the 5th power is x times x times x times x times x. X to the 3rd power is x times x times x, right? So we're just expanding it, again, like we did in the previous problems. Now, remember, when you have factors in the numerator that are the same as factors in the denominator of a fraction, you can just cancel those out. They go away, and you're left with the 2 x's here, which you can put together as x squared. So what you're doing is you're taking the number of x's in the top, and you're subtracting the number of x's in the bottom, and that becomes your new power. 5 minus 3 is 2. There's 2 x's. So that just explains a little bit about why this rule works, and the conclusion of all that is this rule. You just subtract the powers. Now again, you don't have to know any of that. All you have to know is how to use the rules. So now we're getting to the new exponent rules up here. Okay, these are rules that we have not seen in my curriculum yet. Up until now, it hasn't really been that necessary for you to really know these, but again, we're just going to simplify each expression and write the Roman numeral of the exponent rule that we used in the margin, just like the previous problem. So before we even state the rule formally, let me just show you how the rule works. So notice that we have a product of 2 numbers here. We have 3 multiplied by x. Okay, so that's a product inside there, yellow. I'm raising that product to the second power in blue. So I'm raising the product to an exponent or a power. So what you can do, what the next rule that we're going to learn tells us, rule 3, is that you can take one of those numbers and raise it to the second power, and then multiply that by the second number raised to the second power. And that's going to be equal to the original expression. Then you can, simplify this. 3 squared is obviously 9. And then, you don't really need the dot. You can just get rid of the dot, and we have 9x squared. And be aware, you don't really need to write this intermediate step here. I'm just trying to be absolutely clear what's going on. So that is that is rule number 3. So I'm going to write Roman numeral 3 in the margin. So as you can see, this is not really that difficult. Now, let's do number 12. You have -2 times y. So you have a product inside there, 2 numbers multiplied together, and then you're raising that to a power. So you can take one of those numbers and raise it to the third power, and then you can take the other number and raise it to the third power. But I've done something very, very wrong here. If I'm going to take -2 and raise it to the third power, I have to put parentheses around it. That's one of the most common mistakes that students make, is they don't put parentheses. So -2 to the third power, that's going to be -8. And I can just get rid of the dot. I don't really need that. And so that is rule number 3. All right, so now let's try number 13. Now, I want you to understand that the product it can be more than one number. See, we have 4, we have A, and we have B, and you're raising that to a power. So that works the same way. You just take 4, raise it to the second power. You take A and raise it to the second power. And you take B and raise it to the second power. And 4 to the second power is 16. And then you can just put the A squared and the B squared right next to the 16, and you're done. So that is rule number 3. All right, so I want you to try some of these problems. I want you to try number 14, and when you come back, we'll do it together. All right, we're back. So that would just be 5 squared times x squared, and 5 squared is 25. And you can just put the x squared right next to it. And that is Roman numeral 3, rule 3. So if you got that answer, good job. Okay, on to number 15. Try number 15, and when you come back, we'll do it together. All right, we're back. So we have -3 cubed. And like I said, you must put parentheses here. If you forgot to put your parentheses, go back and do that. Because if you write -3 cubed like so, that's not correct. So you have to be really, really careful there. And times y cubed equals, and -3 cubed is -27. And then we can just put the y cubed right next to it. And that's rule number 3. So if you got that answer, good job. If you forgot those parentheses or you didn't get the right sign, that's okay. Just, go back and write the correct answer. So try number 16, and when you come back, we'll do it together. All right, we're back. So we have 2 to the 4th power times y to the 4th power times b to the 4th power, which is equal to 16 y to the 4th times b to the 4th. So if you got that answer, good job. And that's rule number 3. Okay, so you might be thinking, well, these rules seem kind of easy. Well, they are kind of easy, but this is just the foundation information. When we go into the next class, things are going to get a lot more complicated. Now, you might be wondering, why does that rule work? Why does rule number 3 work that way? And again, rule number 3 is restated here. And you should have a screenshot of those power rules right in front of you. Why does rule number 3 work? Why does this work right here? And by the way, again, what it's telling us is that if you have a product and you raise it to some power, then, you just take one of the numbers in the product and raise it to that same power, and the other number in the product and raise it to the same power, and you multiply those together. That's what the rule tells us. And so why does that work? Well, let's take this product here and we'll raise it to the third power. What does it mean to raise something to the third power? Well, that just means you're taking whatever you're raising and you're multiplying it by itself 3 times. So xy times xy times xy. All right, that's just the definition of, an exponent. That's what it means to do that. Now, the commutative rule of multiplication, which we learned in a previous class, tells us that we can order the multiplication any way we want to. So we can change the order of these terms. So why not just group all the x's together and then group all the y's together? Now, if you do that, you can then take the x's and you can change them to x to the third power, and you can take the y's and you can change them to y to the third power. You can put them in that more compact notation. So there you go. Look at the number in green all the way to the left of the expression there, and then you change to the green all the way that I'm circling at the right. That's what the rule tells us. So that's just a brief explanation. Now, you may have listened to that explanation and you may have thought, I don't like that. I don't like that explanation. I don't really quite get what you're talking about. Well, you don't need to know this. It's not necessary at all. All you have to know is how to use the rule. So if you didn't like that explanation or you didn't get anything from it, that's okay. Students are not required to know that. And if I ask 1,000 intermediate algebra students that got an A's in their courses why that works, most of them probably wouldn't even know how to do that. It's not that they can't do it, it's just that they're not required. Okay, so now we're going to simplify each expression below again. Just write the Roman numeral. And so we're going to go into rule number 4. If you look at rule number 4 on your exponent rules, and I'm going to give you one more opportunity to go and take a picture of those if you haven't already done that. Look at rule number 4, and that's what we're going to do now. So what rule number 4 tells us is that if you have a fraction inside here and you raise it to a power or an exponent, then what you do is you take the numerator of the fraction and raise it to that exponent, and you take the denominator and raise it to the exponent. So then you can just take x squared. There's nothing we can really do with that, but 3 to the third power is 9. And there you go. That is rule number 4. So pretty easy. So let's try another one of these. Again, you have a fraction inside and you're raising it to a power. And so we have 4 to the third power over y to the third power. 4 to the third power, that's 64. You can use a calculator if you don't believe me. And there you go. So that was, again, rule number 4. All right, now we have a negative number there, but it's the same situation. So we take the numerator, raise it to the 4th power, and we take the denominator and raise it to the 4th power. But there's something I forgot to do. It doesn't seem like a big deal, but it is a big deal. You have to put parentheses around the negative 3. Because negative 3 to the 4th is negative 81. Negative 3 to the 4th in parentheses is positive 81. What's the difference? Well, there's a big difference. Negative 81 is a lot different from positive 81. So that's really important to put those parentheses. Students constantly forget to put those parentheses. So now we have a to the 4th over positive 81. And that's it. So that is rule number 4. Okay, so I want you to try number 20. Again, this is rule number 4. And when you come back, we'll do it together. All right, we're back. So raise 5 to the 2nd power and b to the 2nd power. And 5 squared is 25. And b squared, you can't really do anything more with that. So there you go. And that is rule number 4. So if you got that answer, good job. Try number 21, and when you come back, we'll do it together. All right, we're back. So we have x cubed over 2 cubed, and 2 cubed is 8. And that's it. So that's rule number 4. If you got that answer, good job. Okay, try number 22, and when you come back, we'll do it together. All right, we're back. So we have -1 cubed, and be sure to put that negative in parentheses, and x cubed. -1 cubed is -1, and x cubed, you can't really do anything to that. Now remember, -1 times -1 is a positive 1, and then you multiply it by another -1, it becomes -1. Okay, and that is rule number 4. All right, if you got those answers, good job. So really quickly, why does that rule work? Why is it that when you take a fraction and you raise it to some power, that you can take the numerator and raise it to the power and then divide by the denominator raised to some power? Why does that work? Well, let's use this as an example. So let's say that you're raising this fraction here to the 3rd power. Well, what does it mean? Think about what it means to raise something to the 3rd power. That just means that you're multiplying whatever you're raising, you're multiplying it by itself 3 times. 1, 2, 3. Yellow, green, blue. Now, remember, if you multiply fractions, you know, what we learned in my arithmetic course and reviewed in my pre-algebra course and my beginning algebra course and my geometry course, over and over again, when when you multiply fractions, you just multiply the numerators. And if you multiply them together, well, you can just write them like that. And then multiply the denominators. And if you put it in power notation, you get x cubed over y cubed. And there you go. So we went from here to here, and that's why the rule works. So we just use an example to demonstrate that. So let's go on to rule number 5 now. So again, we're just simplifying each expression. So look at rule number 5. In this case, we have a power expression that is being raised to another power. Okay. So in that case, what you do is you just write the base, and then the exponent is going to be the product of those 2 powers. So x to the 10th power. And that's it. That's rule number 5. So again, you don't have to write this step. I just did that so you can compare that to the formal statement of the rule. So now we have 3 times 3 is 9. Very easy. So why don't you try number 25, and when you come back, we'll do it together. All right, we're back. So you should have y to the 12th power because it's just 4 times 3. If you got that answer, good job. Try number 26, and when you come back, we'll do it together. All right, we're back. So you should have a to the 30th power because 5 times 6 is 30. You're raising a power to another power. So those problems are so easy that it's not really necessary to do many more of those. Okay, so you might be wondering, why is that? Well, you don't really have to know. Students are not required to know, but if you want to know, let's go over it a little bit with this example. So we have x squared, a power, and it's raised to another power. What does that mean to raise something to the 5th power? Well, that means that you multiply it by itself 5 times. Right? 1, 2, 3, 4, 5 in yellow. Now, if we use rule number 1, remember rule number 1? If you multiply all these together, then you just add the powers. That's what rule number 1 tells us. So if you add all those powers, guess what? You get 10. All right? But notice that it's 2 5 times, so that's 5 times 2 is 10. And that's why it works. So that's just one example to demonstrate our conclusion here, which is rule number 5. If you have a power expression and you raise it to another power or exponent, whatever you want to call it, then you just multiply the powers. All right, so at this point, I want you to practice all the first 5 rules that we learned so far. So I want you to look at your phone or whatever, you should have those rules right in front of you. And again, I'm going to give you one more opportunity here to take a screenshot of those rules. You need these rules in front of you so you can see the number of each rule. And I want you to do each one of these problems, and I want you to write the number of the rule, and over here in the margin. So go ahead and try number 27. Do that problem. See if you can figure out which rule do you have to use to simplify this expression. And go ahead and simplify it, and then write the number of the rule in the margin. Try 27. When you come back, we'll do it together. All right, we're back. So this is actually going to be rule number 4. And that tells us that we changed to 3 squared over a squared, which is 9 over a squared. So you have a fraction and you're raising to a power, and rule number 4 tells us that you just take the numerator, raise it to that power, and the denominator, raise it to that power, and then you simplify, and you're done. Okay, so try number 28. If you got 27 right, that's good. If you got a little confused, then that's okay. You're going to pick these up as you go along. So try number 28, and when you come back, we'll do it together. All right, we're back. So we're going to add the powers, and we get c to the 8th power, and that is rule number 1. So if you got that answer, good job. All right, so be aware you need those exponent rules right in front of you, and you need a number of those rules. So try number 29, and when you come back, we'll do it together. All right, we're back. So this is rule number 3, and it's going to be 4 to the 3rd power times b to the 3rd power, and again, you don't really need a dot in between those. 4 to the 3rd power is 64, and you can just put the b cubed right next to it. So if you got that answer, good job. All right, try number 30. Again, you need those exponent rules right in front of you, and when you come back, we'll do it together. All right, we're back. So this is going to be rule number 5. It tells us that we just multiply the powers, and we get y to the 6th power. So, that easy. All right, so if you got that answer, good job. Try number 31, and when you come back, we'll do it together. All right, we're back. So this is actually rule number 2, and you're just going to subtract those powers. So we have b to the 5th power. So if you got that answer, good job. All right, try number 32, and when you come back, we'll do it together. All right, we're back. So this is going to be rule number 5 again. Multiply the powers, you get b to the 8th power, because you're raising a power to another power. Whenever you do that, you just multiply. All right, try 33, and when you come back, we'll do it together. All right, we're back. So this is actually rule number 1, and you just add the powers, and we get x to the 9th power. So if you got that answer, good job. Try number 34, and when you come back, we'll do it together. All right, we're back. So this is rule number 3, and you've got a product raised to a power. So it's going to be 6 to the 2nd power times y to the 2nd power, which is 36y squared. So if you put a dot in between those, that's okay. If you didn't, that's okay also. A dot is not really necessary. So try number 35, and when you come back, we'll do it together. All right, we're back. So we have x squared over 4 squared equals x squared over 16, and that is rule number 4. So if you got that answer, good job. All right, try number 36, and when you come back, we'll do it together. All right, we're back. This is rule number 2. a to the 6th divided by a to the 2nd is just a to the 4th. You subtract the powers. So if you got that answer, good job. So those were the new exponent rules. Again, we reviewed the pre-algebra rules and this flesh-colored color, whatever you call that color, and we learned new rules here in green, 3 new rules. So we've learned 5 rules so far. But now we're going to go to what I call the strange exponent rules. Now the reason that I call these exponent rules strange is that what we're going to find when we study these strange exponents and strange exponent rules is that these exponents, their operational meaning doesn't correlate with the operational meaning of the exponents that we've studied so far. So let me explain what I mean by that. Let's say that you raise x to the 2nd power. That means multiply x by itself. And if you raise x to the 3rd power, that means multiply x by itself, and then take that result and multiply by x again. So you're multiplying 2x's here and 3x's here. It's pretty easy to understand the operational meaning of these powers and these exponents. But what if we raise x to the 0 power? That's what we're going to study here. What is that telling you to do? Well, this has no direct meaning. It has no operational meaning that correlates with the operational meaning of the exponents that we've studied so far, like x squared is x times x. Well, this is not telling us to do anything. It doesn't really have any direct meaning. A lot of students would say, oh, well, that means x times 0. Well, that's a good guess, but that doesn't make any sense because x to the 2nd power, that's not x times 2. You see the correlation here? But these are not true. So it doesn't make sense that x to the 0 would be x times 0. So what does x to the 0 mean? Well, you can think about this all day long. It's not going to be obvious what that is. What mathematicians do is they actually come up with a definition for x to the 0. They define any number raised to the 0 power to be 1. And you're probably thinking, well, wait a second, where does that come from? Why is it 1? Well, what you're going to find is that when you raise to these strange powers like the 0 power, and down here we're going to raise to the 1st power, that's another strange one. What you're going to find is when you have these strange powers, and you look at their definitions, rules number 6, 7, 8, 9, and 10, those rules, those last rules, those definitions are a result of mathematicians trying to universalize the exponent rules. They want the exponent rules to work for every type of power. They want an exponent to be any real number, including 0 or 1 or a fraction power or a negative power. So you can have all types of powers: 0 powers, 1st powers, fraction powers, decimal powers, negative powers, and we're going to study those later on in this class. And the definitions that they come up with for those strange powers are a result of them trying to universalize the exponent rules. They want the exponent rules to work for all real numbers. So we're going to talk a little bit about why anything raised to the 0 power is equal to 1. You don't really have to understand why it's equal to 1. And by the way, that's rule number 7. You don't really have to understand why this is true, but I'm going to talk a little bit about it just, because you might be a little curious. But b to the 0 power, that's also 1. But the main thing is that you understand the definition. If I take 1,000 intermediate algebra students and ask them why is it that when you raise something to the 0 power you get 1, I'd be surprised if any of them could really explain it. It's not that they're not capable of understanding it, it's just that teachers don't require students to know, so they typically don't even cover it. Now here's an example where you have a base that's really complicated looking, but it's raised to the 0 power, so it's still 1. Now, like I said, here's another example of a strange power. Now, a lot of students look at that and they say, what's so strange about that? You're just raising to the 1st power. Well, think about it. What does that mean? Again, 2 to the 2nd power, that's easy. That's just 2 times 2. But if you're raising 2 to the 1st power, what is it telling us to do? It's obviously not telling us to multiply 2 by itself, because that was 2 squared. Some students, again, they might say, oh, well, that means 2 times 1. but why would it mean 2 times 1? That doesn't have any, that doesn't have any correlation with the operational meaning of, other powers. So it turns out that when you raise 2 to the first power, or any number to the first power, it doesn't change the number, it just stays 2. So that's rule number 6. I know I went out of order there, 7 to 6, but a to the first power is a. So it's very important to understand that these powers have no direct meaning that correlates with the operational meaning of the exponents that we've learned so far. You have to actually translate this to something, because mathematicians have given it a definition, and we're just going to memorize those definitions. Let's go on to number 42. And we're raising a number to the first power. And remember, whenever you raise something to the first power, you don't change it. So it just simplifies to 5a, and you're done. Simple as that. All right, so whenever you raise to the 0 power, it's just equal to 1. Whenever you raise to the first power, it just doesn't change at all. So why don't you try number 43? When you come back, we'll do it together. All right, we're back. 1. That's all it is. If I can make my 1 look like a 1 and not a 7. So that is the rule number 7. So pretty easy. So why don't you try number 44 and number 45 and see what you can get. And when you come back, we'll do it together. All right, we're back. So raising c to the 0 power, that's just 1. And that's rule number 7. Raising anything to the 0 power is just going to give you 1. And again, that's rule number 7. So try number 46. Now we're raising to the first power, and when you come back, we'll do it together. All right, we're back. 23 to the first power is 23. It doesn't change, remember? That is rule number 6. So try number 47 and number 48, and when you come back, we'll do those together. All right, we're back. So again, when you raise something to the -1 power, it doesn't change. It just stays the same. And that is rule number 6. And it doesn't matter what the base is. It doesn't change the base at all. So you just get the same number, and that again is rule number 6. So if you got those answers, good job. So those are the first 2 strange power rules. Now, you might be wondering, why is it that when you raise to the 0 power, you get 1? And why is it that when you raise to the first power, nothing changes? Well, the reason that we define those powers that way is it's an attempt to universalize the power rules in every situation. And so let's give an example of this. Let's say that you divide x to the 4th power by x to the 4th power. Now, you know that whenever you divide a number by itself, you always get 1, assuming that x is not 0. And maybe I should write that somewhere over here. It's not really that big of a deal to think about that exception, but remember, x can never be 0, so maybe I should write that. X cannot be equal to 0, because when you have a fraction, you can't, if you have 0 in the denominator, that changes things. So whenever you divide something by itself, you always get 1. Now, you see this rule over here, rule number 2? Remember what we said about the powers when you're dividing powers? You just subtract the exponents. If the bases are the same, you just subtract the exponents. Well, let's do that right here. Let's subtract these exponents. So now it changes. This expression up here in yellow now changes to this expression based on rule number 2. So now we're subtracting the exponents. But that expression still has to be equal to 1, just like this expression is equal to 1, right? So now we subtract those exponents, and look what we get. X to the 0 must equal 1. So that's just one example to demonstrate the reasoning behind the idea that x to the 0 is always equal to 1. You see, we have that conclusion there. That's rule number 7. And you have to show that that's true for all the other rules if you're multiplying, and so on and so forth. But you don't have to know a complete proof of this. This is just giving you an idea of why this is true. And if you didn't understand that explanation, that's okay. If I pick 1,000 students that get an A in their intermediate algebra course in the country, and ask them why is it that x to the 0 equals 1, I'd be surprised if any of them could tell me. It's not that they're not capable of understanding it. It's just that they're not required to understand it. So the teachers don't even they don't even teach it. Okay, so now we go to some reasoning behind rule number 6. Okay, we're talking about the reasoning behind rule number 7 and the reasoning behind rule number 6. So let's give an example here. Let's say you multiply x to the 5th power by x. Okay, x to the 5th power times x. Now, we learned in my pre-algebra course that when you do that, it becomes x to the 6th power because you have 5 x's and you're multiplying by one more x. So you add 1 to 5 to get x to the 6th power. Very, very simple. That's what we learned in my pre-algebra course. So let's give another example. Let's change, instead of 5, let's change that to some arbitrary number we'll call a. So if you have a x's here and you multiply by one more x, then you get x to the a plus 1. You just add a 1 to that, to whatever this number a is. Okay. But if you compare that to rule number 1 stated here, and you want to come up with a power here, if you want to assign a power to this x, then obviously this explanation here shows us that power must be 1. Because over here we have a sum, a plus 1, and our power rule tells us that we have to be adding some number. But what is that number? What is b? What is the number that's supposed to go here? Well, that number has to be 1. So we conclude that this power here is 1. Whenever you have just an x by itself, the power is assumed to be 1. So there you have rule 6 restated there. X, any number is considered to be raised to the first power. Okay, so again, these rules are not intuitive, and it doesn't make sense to raise something to the 0 power. But in order to universalize these power rules, it's we're given those definitions. Okay, so now let's go on to rule number, I think this is rule number 8. If you look at your power rules over here, again, I'm giving you another opportunity to take a screenshot. That's going to be rule number 8. Now we have negative powers. And you're probably thinking, what in the world? How can we have a negative power? What does that mean? Well, again, it doesn't have any direct meaning. You have to translate it. It doesn't make sense to raise anything to the negative power. Okay, assigning a power as negative is just an attempt to universalize the power rules. So how do we do this? What does this mean? Well, we can't do this. It's impossible. Unless we translate it to 1 over 3 to the 2nd power, which becomes 9. Now again, you're probably thinking, why? Why is this equal to this? Well, we're going to talk about that later on. But now we just need to figure out how to do this. So another problem here, we have a negative power. Whenever you have a negative power, you just write 1 over that same expression, no difference whatsoever, except you're going to change the negative power to a positive power. So then we get 2 to the 4th power is 16. And by the way, I forgot to write the number of that rule, so that's going to be rule number 8. And of course down here, rule number 8 also. And so now let's try 51. 4 to the 3rd power. Again, whenever you have a negative power, you just write 1 over that expression, except now you change the power to a positive, and 4 to the 3rd power is 64. And that's, again, rule number 8. Okay, so now we have a variable, but it's no different. You just write 1 over the same exact expression, except you change the power to a positive number. And actually, there's nothing else we can write there. We're done with that one. So again, that is rule number 8. So now it's time for you to try attempt number 53. And when you come back, we'll do it together. All right, we're back. So whenever you have a negative power, you just change it to a fraction like so. And you can simplify that, and you get 1 over 8. No big deal. So if you got that answer, good job. Try number 54. When you come back, we'll do it together. All right, we're back. We have 1 over 4 squared, which is 1 over 16. So if you got that answer, good job. And that is rule number 8. Try 55, and when you come back, we'll do it together. All right, we're back. So whenever you have a negative power, you just write it as a positive power under 1. And if you got that answer, good job. Try number 56, and when you come back, we'll do it together. All right, we're back. So that would just be 1 over y to the 5th power. If you got that answer, good job. That's rule number 8. Okay, so the big question is, why is that? Why does a negative power become a fraction? Well, again, it's just an attempt to universalize the exponent rules. So if we use this as an example, x cubed over x to the 5th. Now, we haven't done this type of problem yet where the exponent in the denominator is bigger than the exponent in the numerator. We haven't done that in this class, but we have done it in my pre-algebra course. In my pre-algebra course, we learned that you just write the power expression in the denominator because there's more x's in the denominator than the numerator. So instead, if you had x to the 5th over x to the 3rd, then the answer would be x squared. But since it's the reverse order, the x squared ends up in the bottom. So you subtract the powers, but your result ends up in the bottom there. So it may have been a while since you did a problem like that, but that's just the way those work. Now, let's take rule number 2 over here and apply it to this expression in yellow up here. Remember, when you divide powers, you subtract the powers. So now we're subtracting the powers, but wait a second. Because the exponent in the numerator is smaller than the exponent in the denominator, we have 3 minus 5, which is a negative number. Okay, so we know this expression is equal to 1 over x squared. If we change this expression to x to the 3 minus 5, we know, again, that still must be equal to 1 over x squared. And we know that x to the 3 minus 5 must be x to the negative 2 power, which also must be equal to 1 over x squared. And there you go. X to the negative 2 power must be 1 over x to the 2 power, or the 2nd power. So whenever you have a negative exponent, you just convert it to 1 over x squared. Is it really necessary for us to define negative exponents? Not really. But again, mathematicians have a lot of time on their hands, and they want to attempt to universalize these power rules, the exponent rules. And it's also kind of useful when you go into upper math to use the exponent rules and to define all these exponents also. So it's not completely unnecessary. There's actually an application to it. So again, we can now conclude that if you have a negative power, you just write that power in the bottom and change the exponent to a positive, so it becomes 1 over that power. So again, that's if you didn't understand any of that, that's okay. That's completely fine. You're not required to understand this. That's just a brief explanation to show you why that works. Okay, so now we're going to rule number 9. Now we have fraction powers. Things are getting even more complicated. How in the world can you have a fraction power? Well, it's important to understand, just like rule number 6, just like rule number 7, and just like rule number 8, a fraction power has no direct meaning. It doesn't really relate to the actual exact definition of integer powers, or positive integer powers. In order to understand what this means, you have to translate it to something, or it's not going to make any sense. So what does that mean? Well, it means square root 9. That's it, which is 3. And again, I know what you're thinking. You're thinking, why in the world would that be square root 9? Well, remember, this number here is called the index. And for square roots, we don't even write the index. We just assume that it is 2. So that's this 2 here. That's going to be the index. So if you have 8 to the 1/3 power, now the index is 3, so that would become cube root 8, which is 2. And again, that's rule number 9. I know what you're thinking. You're thinking, I don't like this stuff. This is weird. Why are we doing fraction powers? Well, again, it's going to be useful for upper math courses. Technically, you don't really need to define all these strange powers, these strange exponents, but it's like I said, it's useful in upper math courses. So 32 to the 1/2 or 1/5 power, the index of that root is going to be 5, and if you don't know, that's kind of a weird one, but that's actually 2. If you multiply 2 by itself 5 times, you get 32. Okay, so now number 60, that's 1/6, so it would be the 6th root of b, and that's it. And I got to remember to put the numbers of the rules. X to the 1/8 power, that is the 8th root of x. So that's fraction powers. It's very simple, as you can see. And we're going to talk about why a fraction power is equivalent to a root as we go along here. But now it's time for you to try. So attempt number 62, and when you come back, we'll do it together. All right, we're back. So that is going to be the square root of 49. Why? Because the index is 2. We don't write the index, but it's assumed to be 2, and that's this 2 comes from there. And square root 49 is 7. So if you got that answer, good job. But be sure to write the number of the rule. That's number 9. Okay, number 63. Try that problem, and when you come back, we'll do it together. All right, we're back. That's 1/3 power, so it's going to be cube root 27, which is 3. 3 times 3 times 3 is 27, and that is rule number 9. All right, so if you got that answer, good job. Try number 64, and when you come back, we'll do it together. All right, we're back. So that's 1/4 power, so it's going to be the 4th root of 16. What number times itself 4 times is equal to 16? Well, that's 2. That was kind of a difficult one because 4th root of 16 is not that obvious, I guess. But you've seen that before. Okay, try number 65, and when you come back, we'll do it together. All right, we're back. So that's going to be the 5th root of a. And again, that's rule number 9. Try 66. When you come back, we'll do it together. All right, we're back. So that's going to be the 7th root of y. And again, that's rule number 9. Okay, so the big question is, why is a fraction power equal to a root? What in the world does it have to do with a root? Well, here's the reasoning behind number 9. And, if you want to skip over this, you can skip. You don't have to know this. I promise you that, if I chose 100 students out of the country that get A's in their intermediate algebra course, they're not going to be able to explain this. Not because they're not capable, but because they're not required to know this. So that they just don't, teachers don't go over it. And one of the reasons that teachers don't go over it is that, number one, you don't really need to know it in order to go into upper mathematics. But another reason they don't go over it is because if you do go over it, students often fall asleep as you're trying to explain this. They don't really care. So, I don't know how much I want to really go into this, but let's say that you have, I'm not even going to go over that. You can look at that if you want. But again, you're not required to know it. If you have any questions about it, you can ask me if we're capable of doing that. But let's go on to the next rule, the last rule, rule number 10. So rule number 10 is very similar to rule number 9 because we have a fraction. The only difference is in the previous fractions, notice that all the numerators of these fraction powers were 1. 1, 1, 1, 1, 1. You see that? Well, now the fractions that we're going to do, the numerator is not 1 anymore. Okay, the numerator is 3 in this case. So what do we do here? What does this mean? Well, this means you're taking, because there's a 2 in the denominator, that's going to be the root. So it's a square root because it's 2 in the denominator. Remember, the index here is 2, even though you don't write it for square roots. And then what you do is you take that whole thing and you raise it to the 3rd power. And that's it. So again, I know what you're thinking. You're thinking, I don't get why that's true. Why is that true? Well, the explanation is kind of boring. You know, I don't want to bore you. As you know, I skipped the explanation in the previous rule because it's just going to be kind of, you know, difficult to understand and boring. So now what do? Well, PEMDAS tells us to do parentheses first. So square root 25, that's just going to be equal to 5. And then 5 to the, maybe I should put parentheses around that just so you can see that changed to 5. And 5 to the 3rd power, that's kind of a big number, but you know, if you use a calculator, you'll see that that's 125. And there you go, that's it. So that is rule number 10. All right. So now let's do the next one here. So now we have a 3 in the denominator, so that means cube root -8. But there's a 2 in the numerator of the fraction, so we're going to take all that and raise to the 2nd power. All right, and be sure that you use parentheses in these. So PEMDAS tells us to do the exponents first. So cube root -8. What number times itself 3 times is equal to -8? Well, that's just going to be -2. And you definitely need to keep those parentheses. And so -2 squared is +4, and you're done. So that, again, is rule number 10. All right, let's try another one of these. So the denominator of the fraction power is 4, so it's going to be 4th root. And then you raise all that to the 3rd power because the numerator of the fraction is 3. So the 4th root of 16 is 2. And you don't really need parentheses, but I'm just going to write them. And then 2 to the 3rd power is 8. All right, so that is rule number 10. Okay, so the denominator of the fraction in the power is 6, so it's going to be the 6th root of a, and then it's all raised to the 5th power. And that's pretty much all you can do with that expression. So that, again, is rule number 10. 71, same situation. The denominator is 7, so it's going to be the 7th root of x, and it's all raised to the 10th power. There's nothing more we can do with that. That is, again, rule number 10. So now it's time for you to try attempt number 72, and when you come back, we'll do it together. All right, we're back. Okay, so it's going to be a square root because the denominator is 2, and the numerator is 3, so it's going to be raised to the 3rd power. Square root of 4 is 2, and then raised to the 3rd power, and you get 8. So this inside part here, that changes to 2. So anyway, if you got that answer right, good job. That is rule number 10. Try 73, and when you come back, we'll do it together. All right, we're back. So the denominator is 3, so that would be cube root of -27. And then we're going to raise all that to the 2nd power. Cube root 27 is -3, and we definitely need the parentheses. And -3 squared is 9. So there you go. Again, this inside part here became -3. And remember, if you're asking cube root of -27, that means what number times itself 3 times is equal to -27, and that's -3 in blue. So that is rule number 10. All right, try number 74. When you come back, we'll do it together. All right, we're back. So the denominator is 4, so that's going to be 4th root of 81. All raised to the third power. 4th root of 81 is going to be 3. And 3 to the third power is going to be 27. So if you got that answer right, good job. That's rule number 10. On to 75. Try number 75, and when you come back, we'll do it together. All right, we're back. The denominator is 11, so that's going to be the 11th root of b, all raised to the 8th power. So if you got that answer, good job. Try number 76, and when you come back, we'll do it together. All right, we're back. The denominator is 5, so that's going to be the 5th root of c, all raised to the 3rd power. If you got that answer right, good job. That's rule number 10. Okay, so this is the reasoning behind rule number 10. And like I said, you can go over this if you want. It's not that difficult to understand, but given that you're new with these power rules, it's probably best to stay away from this. You're not really required to know it, so I don't want to complicate things. So let's do some more practice on rules 6 through 10. I want you to attempt these problems. It says simplify each expression below and write the Roman numeral of the exponent rule that you used in the margin. The same problems we did before, but now, like I said, we're focusing on rules 6 through 10. So be sure to write the rule number in the margin and simplify that expression. So try number 77, and when you come back, we'll do it together. All right, we're back. When you raise something to the first power, it doesn't change. It just stays 4. So that is rule number 6. If you got that right, good job. You should have your exponent rules right in front of you. I just want to remind you that you're expected to have those rules right in front of you. So try number 78, and when you come back, we'll do it together. All right, we're back. So 1/2 power, first of all, that's rule number 9. And when you have a fraction power, the denominator is the index of a root. And remember, when you have a square root, you don't write anything there. So that would just be square root 64, which is 8. So if you got that answer, good job. Try number 79, and when you come back, we'll do it together. All right, we're back. So this is rule number 8. And whenever you have a negative power, you just bring it down into the denominator of a fraction where the numerator is 1, and the power, everything stays the same except the power changes to a positive. Then you have 6 squared is 36. So there you go. So if you got that answer right, good job. Again, it's very important to write the number of the rules so you can see exactly what is going on here. So try number 80, and when you come back, we'll do it together. All right, we're back. Anything raised to the 0 power is just 1. And that is rule number 7. So if you got that answer right, good job. Try number 81, and when you come back, we'll do it together. All right, we're back. Anything raised to the first power, that just stays the same. Doesn't change, and that is rule number 6. So if you got that right, good job. Try number 82, and when you come back, we'll do it together. All right, we're back. Remember, the denominator of a fraction power is the index of a root, and then you just raise that root to whatever the numerator of the power, or the numerator of the fraction is that's in the power. So now the cube root of 125, that's just going to be 5, and then 5 squared is 25. So that one was a little tricky because cube root of 125 is not exactly, an easy number, but you should be able to figure that out with a little investigation. So that is rule number 10. So if you got that one right, good job. Try number 83. When you come back, we'll do it together. All right, we're back. 100 raised to the 0 power is 1. Remember, anything raised to the 0 power is 1. And that's rule number 7. So if you got that one right, good job. Try number 84, and when you come back, we'll do it together. All right, we're back. So the denominator of that fraction in the power, the exponent, is the index of a root. And because there's, the numerator is 1, you don't raise this. You could raise it to the 1 power, but that's not really necessary because that doesn't really change anything. So if you got that answer, good job. And that is rule number, let's see, 6, 7, 8, 9. That's rule number 9. Okay, try number 85, and when you come back, we'll do it together. All right, we're back. So if you have a negative power, you just write 1 over that same power, no difference whatsoever, except instead of negative, you write positive. So now 10 to the 3rd power, well, that's just going to be 1,000. That should be fairly easy for you to calculate. And let's see, that is rule number 8. So if you got that one right, good job. Try 86, and when you come back, we'll do it together. All right, we're back. So the denominator of the power, that's going to be the index here, which again, if you don't, if it's 2, then you just don't write it. But then the numerator is, you're going to raise it to the 3rd power there. And let me move this up a little bit. So now, what is the square root of 9? Well, the square root of 9 is just 3. And then 3 cubed is 27. So if you got that one right, good job. That is rule number 10. All right, so try 87, and when you come back, we'll do it together. All right, we're back. So the denominator is the index of the root, and 4th root of 16 is 2, so there you go. So that is rule number 9. If you got that one right, good job. All right, try number 88, and when you come back, we'll do it together. All right, we're back. So you just bring it down as a positive power, and it becomes a fraction, and there you go. That's it. So if you got that one right, good job. Okay, try number 89 and 90, and when you come back, we'll do those together. All right, we're back. Anything raised to the 0 power is just 1. So that's rule number 7. If you got that one right, good job. Anything raised to the 1 power doesn't change. So if you got that one right, good job. And that is rule number 6. Okay, why don't you try number 91, and when you come back, we'll do it together. All right, we're back. Anything raised to the 0 power is 1. So that is rule 7. If you got that one right, good job. Okay, so that was just some review of these strange power rules. So now we're going to go to something that I want to go back to the exponent rules, or power rules, whatever you want to call them. See down here it says that x to the b over a is equal to the 8th root all raised to the b power, but it also says it can be the 8th root of x to the b powers. In other words, you can put b on the outside or you can put it on the inside. So is this down here useful to us at all? Well, it turns out that it is useful, and that's what we're going to go over right now. Notice that the problems that we were doing before, they look like this, where the 2, see this 2 here? The 2 was on the outside. These are the problems that we did before. But now the 2 is on the inside. And, but that's okay. Let's see if we can still calculate. So order of operations tells us to do the inside part first. Actually, it doesn't really specify in detail, but technically that's what the order of operations tells us to do. So we have to do 27 to the 2nd power. But wait a second. 27 to the 2nd power, that number's too big. So we don't want to do that. But we can actually change the form of this. we can change it so it looks like the form we were using before, and now the 2 goes on the outside. That's equivalent. So, you know, it's very important that you understand that, you know, when it says in rule number 10 that it can be this expression or it can be this expression, you know, that means that these two are equal. So, you know, it's very important. And maybe I should just set those equal in the exponent rules so it's absolutely clear. But I explained that here, that, you know, those two are exactly equal. And so, but you know, who cares? What's the point? Well, the point is now we can do the problem a lot easier, because again, we do the inside part first, but the cube root of 27, that's really easy. That's just 3. And now if you square 3, we get 9. So we did it in a way so that you didn't have to square 27. Okay, so that's the reason that variation is important. And I might write the variation, you know, up here in the notes, just so you can see exactly what we're doing here. So let's try 93. I'm going to put the power on the outside, because again, that's the whole point of the rule, because we don't want to cube 25. That would be a huge number to have to cube. So now we can just find the square root of 25, which is 5, and 5 to the 3rd power. That's a big number, but it's a number we can manage. That's just 125. And by the way, I forgot to put the number of the rule that we're using. This is still rule number 10. Okay, so let's do one more of these. So I don't want to square 16 because that number is really big. There are some tricks to square numbers really easy, but we don't need to go into those. So I'm going to put the 2nd power on the outside, which is completely legal based on the rule number 10. So now the 4th root of 16, that's just 2, and now 2 to the 2nd power would be 4, and you can see it was a lot easier to do it that way than to have to square 16. So you might see some of these problems, and you'll get to this point and you'll just think, man, I don't want to do that. Well, you don't have to, because, you know, you can just put that square on the outside. So I'm going to leave the first 3 problems we did there in the window, and I want you to try 95, and when you come back, we'll do it together. All right, we're back. So we don't want to do 8 to the 4th power, so we're going to take that power and we're going to write it on the outside, and now we cube root 8 first to get 2, and now the problem is a lot more manageable. 2 to the 4th power is 16. So if you got that one right, good job. Okay, again, we don't want to do 9 to the 3rd power, so see if you can fix that. Try 96, and when you come back, we'll do it together. All right, we're back. So I'm going to put the power on the outside, and now square root of 9 is 3, and 3 to the 3rd power is 27. So if you got that one right, good job. Okay, try 97, and when you come back, we'll do it together. All right, we're back. So I'm going to put the power on the outside. Now the 4th root of 81, that's just going to be 3. And so we have 3 to the 3rd power, which is again 27. So if you got that one right, good job. That's rule number 10. Try 98, and when you come back, we'll do it together. All right, we're back. I don't want to have to square 64, so I'm going to put that square on the outside, cube root 64, which is 4, and 4 squared is 16. Now, if you weren't sure what the cube root of 64 was, well, you know, you can just think about that, and it should be fairly easy to figure out. Just try some numbers, and you'll figure out what it is. Okay, so try number 99, and when you come back, we'll do it together. All right, we're back. So I don't want to do 16 cubed. So what I'm going to do is I'm going to put that cube on the outside, and square root of 16 is 4, and now 4 to the 3rd power, that's a lot easier. 4 to the 3rd power is still a big number, but it's a lot easier than having to deal with 16 to the 3rd power. So that's rule number 10. Okay, so good job on those problems if you got them right. If you didn't, that's okay. Just go back and figure out what you did wrong. Now, this is the justification for why that variation of Rule 10 works. And I'm not going to get into it, because, again, it's just going to complicate things. You don't have to know this. This looks really complicated, but you don't have to know it. And a lot of students would say, well, wait a second, I have to know it. It's part of the curriculum, right? I got to know it. No, you don't. Again, if I take 1,000 students they got an A in their intermediate algebra course, or even if I took 1,000 college students, I would be surprised if one of them would know it, because you're just not required to know it in school. So now what we're going to do is we're going to put all those rules together. Okay, rule 1 all the way to rule 10 in a problem set here. So we're just going to do a little bit more review. And so I want you to identify the rule and write the Roman numeral of the rule in the margin, just like we did before, and simplify the expression. So go ahead and try number 100. And again, we're combining all the rules. We're not doing more than one rule in one problem, but we're putting all the rules here. So you have to look back to all your exponent rules and be sure you have those exponents right in front of you, because if you don't, you're not going to be able to get through this. So we're going to just do one more problem set and we'll be done for the day. So try number 100, and when you come back, we'll do it together. All right, we're back. This is rule number 8. Any negative power, you can just write it as a positive power under 1. And 2 to the 5th power, that's kind of a big number, but you can figure it out. It's just 32. So if you got that one right, good job. Try number 101, and when you come back, we'll do it together. All right, we're back. We're raising a power to another power, so you just multiply the powers. And I'm going to go ahead and write that in intermediate step, even though we don't have to, just so you know what's going on. So that was rule number 5. So if you got that one right, good job. Okay, try number 102, and when you come back, we'll do it together. All right, we're back. Any number raised to the 0 power is just 1, and that's rule number 7. Try number 103, and when you come back, we'll do it together. All right, we're back. When you're multiplying powers and you have the same base, you just add the powers, so that would be x to the 17th power. And that is rule number 1. So if you got that right, good job. Okay, on to number 104. Try 104, and when you come back, we'll do it together. All right, we're back. So when you're raising a product to a power, you just raise each of the numbers in the product. And 7 squared is 49. So there you go. And that is rule number 3. So if you got that one right, good job. Now notice this one has a star by it. That's because you don't want to raise 8 to the 5th power. So see if you can work that root or that power around a little bit and see if you can figure out how to do it without raising to the 5th power, 8 to the 5th power. Try number 105, and when you come back, we'll do it together. All right, we're back. So I'm going to rewrite that as cube root 8 raised to the 5th power. And that's a lot easier because cube root 8, that's just 2. And now I have 2 to the 5th power. That's so easy relatively. It'll just be 32. And that is rule number 10, actually a variation of rule number 10. Maybe I should put a little prime symbol there so you know it's the variation of rule 10. Okay, try number 106, and when you come back, we'll do it together. All right, we're back. Anything raised to the 1 power is just itself. It doesn't change at all. So that is rule number 6. If you got that one right, good job. Try number 107. When you come back, we'll do it together. All right, we're back. When you're dividing powers, you just subtract the powers. That would be 7 minus 4, which is 3. And you don't have to do this intermediate step here. but I'm just doing that to demonstrate. So that is rule number 2. If you got that right, good job. Try number 108, and when you come back, we'll do it together. All right, we're back. So the denominator of the fraction in the power is the index, so it's 7th root of x to the 6th power. Whoops. Actually, we're used to writing it this way. You can write it with the 6 inside also. That's the same thing. So if you got that answer, good job. That is rule number 10. So try number 109. Again, there's 2 ways to do this. So if you did it the other way with the 6 inside, that's okay. Try number 109, and when you come back, we'll do it together. All right, we're back. So you have a fraction raised to a power, so you just raise the numerator to that power and the denominator to that power, and it's extremely important that you write the parentheses there. And negative 4 squared is 16. And why do you have to write the parentheses? Well, because you have the negative there. If you don't write the parentheses and you just write negative 4 squared like that, then you'll end up with negative 16. That's not correct. It's positive 16 because you're raising the 4 and the negative to the second power. Try number 110, and when you come back, we'll do it together. All right, we're back. I realize we didn't write the number for this one. That is number 4, rule 4. And for number 110, anything raised to the first power doesn't change. That's rule number 6. All right, try number 111. When you come back, we'll do it together. All right, we're back. This is rule number 5. When you raise a power to another power, you just multiply the powers. So that's a to the 2 times 10, which is a to the 20th power. And that's rule number 5. So if you got that right, good job. Try number 112, and when you come back, we'll do it together. All right, we're back. So if you have a negative power, you just write the power under 1, and you change the power to, or the exponent to a positive. And 9 squared is 81, and that's it. And that is rule number 8. So if you got that right, good job. Now there's a star by this one. That's because we're going to have to use that variation. Remember, you don't want to, it's a variation of the rule. You don't want to raise 9 to the 4th power because that's going to be a big number. So see if you can work that power around there to make it easier. So you don't have to raise 9 to the 4th power. Try 113, and when you come back, we'll do it together. All right, we're back. So I'm going to rewrite that as square root 9 raised to the 4th power. Square root 9 is 3, and 3 to the 4th power is 81. So there you go. And that is rule 10. Okay, so moving on here. If you got that one right, good job. Try number 114, and when you come back, we'll do it together. All right, we're back. Anything raised to the 0 power is just 1, and that is rule 7. So if you got that right, good job. Try 115, and when you come back, we'll do it together. All right, we're back. Multiplying power expressions, you just add the powers, so we have a to the 12th power. And that is rule number 1. So if you got that right, good job. Try number 116. When you come back, we'll do it together. All right, we're back. So that the denominator of the fraction is 4, so the index of the root is 4. And that's it. And that is rule number 9. So if you got that one right, good job. Try number 117. When you come back, we'll do it together. All right, we're back. So on this problem, you have a product inside, and you're raising it to some exponent, some power. So you just raise each one of the terms in the product to that power. So negative 4 to the 3rd power, that's kind of a big number, but negative 64 is what we're looking for. And you can just write the other numbers, and that's our answer. So we got that one right. Good job, and that is rule number 3. All right, try number 118. When you come back, we'll do it together. All right, we're back. You're dividing powers, so you just subtract the powers. You don't have to write this intermediate step, but I'm just going to write it so you see what's going on. So we have a to the 6th power, and that's it. So that is rule number 2. If you got that one right, good job. Try 119. When you come back, we'll do it together. All right, we're back. So we have a fraction power, and the denominator of the fraction is 3, so the index of the corresponding root is 3. And whoops, I forgot to, that should be outside. I could write it on the inside, but that would make things really difficult. So cube root 8 is 2, and 2 to the 5th power is 32. And that is rule number 10. So if you got that one right, good job. Try number 120. When you come back, we'll do it together. All right, we're back. So when you raise something to the 1 power, it doesn't really change anything. So you're just left with the base, and that's it. And that is rule number 6. So if you got that one right, good job. Try number 121, and when you come back, we'll do it together. All right, we're back. The denominator is the index of the root, but whenever you have a 2 for the index, that means you don't really do anything. It's just, or you don't write the index. And that is rule number 9. So if you got that one right, good job. All right, try number 122. When you come back, we'll do it together. All right, we're back. So you have a fraction raised to a power, so you just take the numerator, raise it to that power, and take the denominator, raise it to that power. 2 to the 3rd power is 8, and so we have 8 over a to the 3rd power, and that's it. And that is rule number 6. Actually, no, not 6. That's rule number 4. So if you got that one right, good job. And so that is the class today. We got a lot of practice with the basic power rules. And I forgot to write a prime here. That's a star. That's a star problem there. Okay, so if you want to take screenshots of all the work that we did today to help you with your homework or to study for tests, you can go ahead and do that now. Here's screenshot number 1. And screenshot number 2. And number 3. And number 4. And number 5. And number 6. And number 7. And number 8. And number 9. Now don't go before you get your homework. Let's take a look at the homework. Here's the homework. Get a screenshot of these first 2 pages. And a screenshot of these next 2 pages. And here's the answers for the first 21 problems. And here's the answers for numbers 22 through 44. So be sure to do that homework. There's some work that you can show for these problems, so be sure to show work when you need to show it, or when it's really necessary to show it. Obviously, if you're raising some number to the 0 power, there's not really a lot of work to show there. But there's a lot of these problems where you can show some work. Also, make sure that your homework has those 4 characteristics. So get that homework done, and I'll look forward to seeing you in the next class.